Okay, good. Keep forgetting about this. Well, good morning. I'm only 8 hours adrift, having arrived in Seattle at 6 o'clock last night. It's delightful to be here. As ever, in these kind of talks, I feel as if I am like the tip of an iceberg, the bit that sort of thrust briefly above the surface. But you are the body of the iceberg. You're all there sort of holding this up. So this is very much a sort of collaborative, interactive kind of talk. Maybe if I say things that you have something to say about, you can just contribute. So we have another microphone, do we? No, we do not have another microphone. No, this is the only microphone. Yeah? What was that? Yes, I'll repeat audience questions, but if you'd like to sort of contribute to anything, any feature or thing that I'm talking about, then stick your hand up and I'll just give you the microphone, right? So then we'll all learn from each other, all right? So this is a brief summary of the state of affairs in GHC land. So here we are. Since the last ICFP, this is more or less trying to cover the last calendar year. Yeah. Oh, man. What is that? That's not my computer. My computer has no such background. And it's clearly saying, I can see what it's saying on this screen. Is it some mysterious mixing thing?
I'm sorry, right now.
Oh, that's your background, yes. Aha, how about just unplugging it? That would... Okay, well, I can see the slides anyway. And YouTube can see the slides, just that you can't. So I will read them to you until we... in the last calendar year, what releases have we had? In August last year, GHC 9.4.1, and since then there have been no fewer than 6 minor releases, kind of bug fix releases coming out since then. The last one, 9.4.7, was released just days ago, I think. Then 9.6 was released in March this year. Remember, we're on a kind of roughly 6-month cadence, and we've had 1 minor release since then. And 9.8 is on the, it's on the, what's the word, when they launch a ship, it sits on those blocks and then you cut the cables and it rolls into the sea. So Ben is about to cut the cables and roll it into the sea. October, we think, right? And 9.10 is already kind of in preparation. We're expecting to fork the tree in January. Now, here's a bit at which it really would be quite nice to be able to see the screen. So you might wonder about these dates, like how do you get to know these dates? So people are asking that to us during the year. And so what we have got now is a GHC status page that I promise, show you, that says, I tell you what, I could plug my machine in instead of yours, couldn't I? Since it's displaying, it's HDMI cable, since we're displaying that, I could just move this over here and you could have it. What was that? It's not the laptop. Oh, right into the projector. Oh, look. Just holding it in the air did the job. Or else you did something. Or maybe you did something. Or maybe it was just holding it in the air. So here is the, here's the GHC status page, which from now on, we promise will be kept remorselessly up to date. So here it is. It should be easy to find. I'll show you how to find it. But it says here, what are the next planned release? What is the status page for each? And if you follow this percent thing, means is the GitLab notation for milestone. And if you follow this link, you'll get to a little page. Here's the one for 9.8.1 that gives the schedule, including all the, the alpha releases and release candidates and so forth. So that should mean that on any day you can find out what the status of all releases is in. And there's quite a bit more on this page below. Down here, scroll down, there's quite a bit more. Search for GHC status page, you'll find it. Okay, so far so good. Now, 9.6, so here's a quick roundup of what's in the compilers that we've released since this time last year. 9.6, what was in 9.6? Delimited continuations. This is, for me, this is the big one. So Alexis, just tell us briefly about delimited continuations. You've got some text here to support you.
Yeah,
I didn't really warn you.
I've already included an entire talk on delimited continuation, so this will not be quite as long as that. But basically, we have these 2 primitive operations for capturing the continuation. They're very simple. It would be great for people to use them. Let's see. I guess, so the way that currently we handle things is very naive, and it seems to perform pretty well. So I think kind of the plan was we would implement things in a very simple way, and then hopefully people will give us bug reports. And so far, I don't think we've received any bug reports, but it would be great to get bug reports. But yeah, use them.
But it's the pathway to, among other things, efficient effect handlers, right? Is this still working? Hello? Yeah, it is? Okay. All right. So for me, this is a big piece of sort of big step forward, qualitatively new thing that GHC hasn't had until recently. Okay, here's a smaller but useful thing. When you declare a data type, all the data constructors can be made available as types. Remember, like this is called data kinds, isn't it? But Yavor has been long arguing, saying you should be able to, when you declare a data type, to say I want it only to be available at the type level, and I don't want to put those funny tick marks in front of the data constructor names. This is a sort of namespacing thing. So this is a small quality of life improvement. You will notice in this talk that lots of these slides have a URL at the top. The slides will be available afterwards. A lot of this is being driven by the GHC proposals process, right? This is Yavor's proposal. And likewise, here's Alexis's one, which is the result, by the way, of a lot of work. There was many iterations of that proposal. Okay, anything else to say here? Yeah, right.
One clarification here is that Yavor, I think, originally proposed this idea, or is one of the original proposers, but Ross Patterson was the person who actually implemented this. So I think most of the credit goes to Ross for actually like pushing this into GHC itself.
I'd forgotten that. I just naively took the author of the proposal. So thanks. Good. Here's another small quality of life improvement. When you do an update of a record that contains existentials, which sounds exotic, but people do it, right? Then what is going to happen? Well, so here's a record which contains an existential. Look, it's got this existential field A that doesn't, or type variable A, that does not show up in the result type, right? So if you're going to update this record, you must simultaneously update flood1 and flood2 with mutually compatible values. Does that make sense? Right? And so for the longest time, GHC couldn't really do this because I was heroically trying to type check the original program that the programmer wrote, right? And rather than, say, first desugaring it into the case expression that it stands for, and then type checking that. But that became insupportably complicated. It's really quite hard to type check this directly. It's just easier to desugar it first and then type check it. But for a long time, we have not wanted to. Have I got a second slide for this? Yes. We've not wanted to do that because you get worse error messages. So this is a little tip of the iceberg thing that says that now for some constructs we are desugaring them before type checking, but we are also keeping track in the implementation of the old pre-desugared thing. And we are careful in type checker error messages, there's a systematic way of doing this, to make sure that we never mention bits of syntax tree that were not in the original program. Does that make sense? So, as it were, the desugared program has bits of syntax tree that come from the desugaring, and then you get back to old stuff that was part of the original tree, and the source location information keeps track of which is which. So I think we're going to see much more of this. Apurva, where are you? He was here. He's in another room, right. So we're going to do this for do notation, but there are quite a few open bugs about do notation and applicative do that essentially amount to the same thing, that it was too complicated to get, particularly in combination with rebindable syntax, right? So it's hard to get all these moving parts to work together. So now we're just going to do more desugaring in advance with careful attention to maintaining good error messages. I think it's good plan. So, but Carrie MY, who I've never met in person, you're not here, are you, Carrie MY? No? Heroically did this for records. Okay? But watch out for this, because I think this will be, you'll see more of this. Indeed, you may get involved in doing some of it yourself. Loiter and Cheng have heroically been working on backends for WebAssembly and JavaScript, respectively. So, Loiter, do you want to say anything about this?
Well, I can't claim all the credit since Jeff and Josh have been doing lots of the work. But this has been a fairly long-going project known as GHCDS for a while, but it's been very hard to keep up with the change of progress of GHC that's been increasing, and I'm happy that we are getting closer to having it less non-standard, just having a different cross-compilation backend. And a lot of things had to be changed to make GHC more cross-compilation friendly, and I'm very happy that we're getting there. It's still not quite to the point of feature things. We still need to work on an optimizer, and template Haskell has landed very recently, but that's pretty much it. I hope everyone will try it out.
Yeah, there's a long saga here, right? And it's not done, right? So I put here, by no means done, and full of volunteers needed. So I think people will be very happy to. So Anil.
Which version of WebAssembly are you targeting for the Haskell backend?
Which version of WebAssembly? So this is really Cheng's question, but Cheng isn't here, I think.
It's the MVP, the so-called MVP of WebAssembly. So right now, the next WebAssembly will include a garbage collector and all these things, but we assumed a much simpler WebAssembly, only the MVP. Yeah.
So I think this. I have a feeling it's kind of like there's something viable is working, but I feel as if the first 10% has been done. There's quite a long way to go here, but it is but it's pretty exciting. Okay. What next? So more compiler and runtime system quality of life improvements. So one thing is that actually this was a customer, wasn't it? Someone who uses GHC was finding that template Haskell was very slow. And why was it slow? It was because it was linking. When you run a template Haskell splice, you have to run code that's in some other module. How do you do that? Well, you link the other module, and the linking process turned out to be slow. So this prefer bytecode flag instead looks in the interface file, which we have, which of course you must have loaded already in order to use that module at all. And in the interface file is all of the core for that module, and we can compile that core to bytecode on the fly, right? And that, surprisingly, is a lot quicker than linking. I don't know why that is. Ben just looked at me and he said, "It's just slow, Simon." Anyway, it's but the result, this is pretty significant, right? Compiling 40% faster makes a big difference in people's lives. Let's see. Who already knows what info table provenance is? See, okay, about 20% maybe. So I'm going to tell you, because Ben had to educate me about this last night as well. So whenever you allocate a closure in code, like say let, in your code you say let f equals lambda x blah blah blah, a local function definition, or a thunk let x equal y plus 1, then you're going to build you're going to allocate at runtime a little closure that contains the free variables and a code pointer. The code pointer, of course, points to the code to evaluate that closure, but it also has information that describes the layout of the closure and stuff like that. It's metadata. But it can also include a pointer that says, well, that closure came from this piece of source code, right? It's sort of statically related. So that's called the provenance of the info. The info table is the metadata. The provenance of the info table is which bit of source code allocated it. Right, that's good, but what happens if it's a constructor? Like you say, let x equal y cons y's locally in the body of a function definition. Well, a cons cell, back in the days when we were just thinking about cons, in the original design, a cons cell, its info pointer, its code pointer in the closure, it's still got a little heap allocated closure, it just points to a single fixed cons cell, which of course tells you nothing about which particular cons cell allocation site gave birth to it. Right? So the trick is simple. Just make a new copy of that cons info table, one for each allocation site. And of course that makes your binary bigger, but it means when you're crawling over the heap, and Ben spends his life crawling over the heap, then you can say, oh, that cons cell was allocated right there, and that can make a big difference. So that's been in GHC since 9.4, 9.2, something like that. These changes here are to reduce the overheads. Right, so the costs, the static costs of capturing all this extra provenance information, and they make quite a big difference. Right, so.
And to clarify, this was also a sort of client project that WellType undertook because they were our client wanted to ship this their binaries with IP information to their clients
In production code.
in production code. And you ship a 500 megabyte binary to your clients, they tend not to be very happy. So we're slowly chipping away at this.
Production code never crashes, so why would you need this? Okay, I'll pretend I didn't answer that question. And also, this is also credit to Ben and well-tapped customers, I think, pause time improvements in the non-moving garbage collection. So the non-moving garbage collects incrementally with the game of reducing pause times, and you have substantially reduced pause times. Yeah, that's in 9.6. Yeah. Okay, so good improvements. Error codes. Who knows about error codes? Hands up if you already know about error codes. Okay, so maybe close to the majority. So just a reminder that we're moving from error strings, this is the compiler produced errors, from strings to a data type, and moreover, every constructor of the data type, or every distinct error within it, has a distinct error code. Why is it good to have a code, an actual number? Well, it means you can look it up in the Haskell error index. So this is a Haskell Foundation project. This I did show you last year. Here's an example of the error index. It's got lots of GHC error things here and a summary of what it means. Of course, you can Google for the error number. That's good, right? Much more greppable than the grepping for the string. Much more Googleable, and you get a page of description about what it is and how it might arise and how to fix it. Of course, I don't think we've got write-ups for every error by any means. So this is another thing that you could do, is to pick some errors and to add to the Haskell error index, which is it's not even part of the GHC repo. And the last thing to say about the error index is it isn't just GHC, right? This error index is covering GHC up and stack, and here at the bottom are a few GHC up and error messages. So if you're a user of Cabal or stack or GHC up, and you come across an error, you think, finally I figured out what it means, can you submit a pull request to the error index for them too? Right? And they're distinguished, as you can see, by the prefix S and GHC up and GHC. Okay? So I think this is pretty in the big scheme of things, this is a fairly big deal. Seems mundane, but actually the aggregate effect of all these little snowflakes is significant. Did I miss anything here? Yeah, no, nothing. Okay? All right, so that's 9.6. That was only 6 months, right? So 9.8, what's in 9.8? This is a personal favorite. Yaro's not here, is he? No. So have a look at this quote from Duncan Coots's thesis, right? The most significant remaining practical work on stream fusion is to resolve the problem with effectively optimizing uses of Concat Map. So this is like by the way, this is 2010, so this is like a 15-year-old, more than 15-year-old problem with fusion, right? Called the Concat Map problem. And here it is, the rewrite rule that we want says Concat Map applied to lambda x stream next f of x rewrites to concat map prime of that next there, and that f, that f. Ooh. That f is a function, right? So in a use like, what we'd like to write, syntactically is no problem. Here it is, visualized in GHC syntax. Here's a rewrite rule. Concat map lambda x stream next f of x. Oh, and by the way, it's quantified for all next and for all f's. Right? Not for all x, because x is bound here. But the idea is we're going to match the left-hand side, get bindings for next and f, and then spit out the right-hand side as the optimized thing. And this one line of code is the thing that makes stream fusion work nicely. Okay? And we haven't been able to do it. And why haven't we been able to do it? Because it means matching to get a binding for a function f. So if I have something like this, lambda, if I have a call, concat map lambda x stream next g of x plus 1. That doesn't look like f of x, right? Look, it looks like g of x plus 1. That's not f of x. But of course it could be if I chose a suitable f. The f that I want is lambda x g of x plus 1. So, we've known about this for some time, and we thought, that means high order matching. And you look at papers on high order matching and they make you want to lose the will to live. And it's undecidable and it's all bad. So I've always just taken this as being, gospel, that you can't do high order matching in a tractable way. And Yarrow said, but Simon, look, here's an implementation. I said, Yarrow, it can't be done. And and we went to and fro like this for a bit. And after a bit I thought, he has a point. And it turns out that he'd identified a little sort of subcase that can be done rather well and very easily that was not really documented properly in the literature. You could, if you looked at some past papers with the right kind of eyes, you could see that it was there. You know, the people who wrote these papers knew about this, but there's a little case that says if you've got this expression here, right? So in the pattern, there's the pattern, and it consists of a pattern variable f here for all f applied to what? Well, sorry, I beg your pardon. It's an expression whose only three variables are one of these template variables and a bunch of locally bound variables like x. And you'll have to read the user manual to see the exact rules. I'm not going to drag you through them now. But the point is there is a very tractable subcase of higher order matching that is just powerful enough to do this. So the reason I made a bit of a meal of this point is because Yarrow implemented this. It's in GHC 9.8, but it's been like throwing a stone into a pond. I expected there to be tidal waves of enthusiasm and people building new libraries with clever rewrite rules, but no, nothing. So guys, this is amazing. Try using it. Okay? All right. Custom warnings. This is about again about quality of life for users here. This is saying, look, instead of at the moment you can say you can get a warning if you use head, right? But that's a warning that you can either switch off all warnings or no warnings. And you don't want to switch them all off. So it's a way of categorizing warnings so that you can write something like this that says, oh, I'm creating the category x-partial, and then in your in your invocation line, you can say, please warn me on x-partial warnings, or please suppress x-partial warnings. Right, so you could just divide your warnings into categories. So it's something that library designers can use to control to allow you control over what warnings you get or don't get from their libraries. Okay, I think it's quite right. In the same spirit of controlling warnings, deprecated exports. So here, this function lines is here being exported, re-exported from data.list. It's not actually defined in data.list, and it's a perfectly respectable function, you know, defined in some module and exported from there. But data.list is re-exporting it, and this deprecated pragma says, please don't import data lines from data.list. Instead, get it from data.string. Okay, so for whatever reason but the point is you couldn't do this before. You could either deprecate lines entirely for all users, which is not good because lines is a perfectly good function. This allows you to deprecate the place that it's imported from, which allows you to transition module structure, right, when you change the structure of your modules. Okay. So, yep, another GHC proposal. Unsatisfiable constraints. This is to do with when you want to have user level or library level control over type error messages. So again, you go and read the initial proposal, but I've take this one here. If you've got an equality instance for A arrow B, well, one possibility is to just say, do not provide an equality instance for A arrow B because you can't take equality of functions. But then GHC says no instance for A arrow B. Now, for equality on functions, you might say it's obvious enough, but if it's a domain-specific library and they say no instance for C of T of A, then you think, why isn't there an instance for C of T of A, right? But so this way you can get a decent error message. This says, oh yes, GHC thinks, fine, I've got an instance for EQ of A arrow B, and here it is. It says, oh, but to do that, I've got to prove unsatisfiable, and it can never prove unsatisfiable. Instead, it just prints out the message. And what is the message in this case? Well, you can make a message that says something like, don't use the equality instance for arrows because you can't compare functions for equality. Does that make sense? So it's about domain-specific error messages. And you can do it not only for instance declarations, but also for functions that you couldn't call. The proposal has quite a few more examples. It doesn't give you any new expressiveness. It gives library designers new ways to offer feedback to their clients. Okay? All right. Many of you will know that there's been a long strand of work on dependent Haskell, and it can be quite difficult to keep track of it because there's quite a lot of moving parts. So in this slide, I've just tried to summarize where things are at. So particularly, I suggest you look at this stage. Look, here's the URL, and here's a status page, which I use myself for keeping track of what the moving parts are. And it also has a pointer to the overall design plan, right, that says, what are we trying to do? How far are we trying to go? Because dependent types is not one destination in language design space. It's a whole little sub-universe of destinations. And it's easy to get confused, and it's easy for people to talk past each other because you think you're actually talking about different things in the destination space. So this design for dependent type says where we're heading. It's a GHC proposal itself. And this status page keeps track of where we are on implementing it. I think at the moment we're quite a lot in the stage of doing consolidation. Here is a consolidation thing that's in 9.8. You'll know that in a function call or in a type, you can use visible type applications, which means you can say f at t, x, y, z, meaning call f instantiating its first type argument to t. That's called visible type application. It's been in GHC for quite a while. But what we haven't had is visible type abstraction, right? So here is a data type t. It's got a separate kind signature, which has been in GHC since 9.2, standalone kind signature. So this is saying that the type constructor t has kind for all k, k2, for all j, blah, blah, blah. And now for the first time with this change, again, a GHC proposal, you can explicitly bind the k in the data type declaration itself. Right? So here I want to say, in the data type declaration, I want to say a as kind k, but where did k get bound? Previously it was bound by a sort of implicit binding mechanism on the left-hand side. It was never terribly satisfactory. Now we can just bind it absolutely explicitly here and here. Does that make sense? So I see this as being kind of like filling out the design space, right? That as soon as we got all this kind polymorphism, of course you would want ways to say this kind of stuff, and we didn't really have it before. So it was got it implicitly there, and now it's explicitly there. It doesn't add it directly any new expressiveness. There is one breaking change that I want to bring your attention to, which has been a wart on the language that I've hated for a long time. If you declare a type synonym, just an ordinary old Haskell 98, well, not Haskell 98, type synonym, and you say type T1 equals nothing with kind maybe A. What does that mean? Where is A bound? A's not really in scope there, right? So up to now, GHC has had some magical mechanism that says, well, look at the right-hand side, and if there are any kind variables that are not already in scope, then pretend that you bound them on the left-hand side. Right? It would be better, a better principle would be to say, variables mentioned on the right should be bound on the left. I mean, if I said type T of A equals A arrow B, you would say, what are you smoking, Simon? Right? You've got a B on the right and no B on the left. That would be bad. And so now you can say A on the left, and you must. I forget exactly about the sort of deprecation plan for this, but now the idea is things mentioned on the right should be bound on the left. Right? And this is the way God intended this to be done, essentially. And we were sinning before. So it's part of, and these things cause a lot of pain and angst because we have to think, how are we going to break people's programming and how are we going to have proper deprecation cycles? Pay a lot of attention to this stuff nowadays, but at the same time, it does seem important eventually to get to a destination that you can defend rather than this kind of nonsense. Okay? Anybody got any questions about, do I want to say anything else about dependent Haskell? No. But I know that this is territory in which there's quite a lot of discussion some of the time, but I think it's moving slowly but steadily and quite conservatively, actually, in the right direction. Anybody want to add anything to that? Richard, you got anything to add? No? All good? You're being terribly quiet, This is not really a sort of Haskell-y audience. Maybe it's because it's all so uncontroversial. Maybe I should try to say something more controversial. Okay. This one I don't. Ben, why don't you describe this one because I've been talking enough.
Sure. So this is a long-standing sort of low-hanging fruit when it comes to improving compiler time. Typically, you're not compiling just one Haskell library or one program. You're rather compiling a whole suite of packages. You're using a program such as Stack or Cabal to do so. And up until now, we've not really had a great way to allow you to use the full extent of your machine's parallelism that you have available. Yeah, you have there's 64 cores now with for a few $1,000s. So why can't we use that parallelism? Well, because it's complicated. But now we actually can, right? So we have this ability in GHC to be able to use this mechanism, which we call parallelism semaphores, allowing multiple GHC processes and, in fact, multiple compilers in general. This is a very there are linkers and some C compilers also support this. Make does as well, similar mechanisms to allow compilers within a build, a multi-language build even, to distribute work among cores and ensure that you don't oversaturate the machine. And this actually can allow you to not only, up until today, you typically have had to be very conservative in how much parallelism you allow, for instance, Cabal to use. Now you can actually tell Cabal, use my machine to the extent you can use it, and you'll actually get a rather remarkable speed up in many cases. So here we see almost 50% speed up on a fairly typical build plan and system. So hopefully this will help. Yeah.
Let's do a quick tutorial on how it works. So if you're Cabal, right, and then I'm one copy of GHC that you've invoked, and Alexi is another copy of GHC that you've invoked, and Richard is another copy of GHC, and you've invoked all of us, right? Then we each, and then you're Cabal, right? And then Ryan is the parallelism semaphore thing. Is that right? Cabalism, okay. And so, as one copy of GHC, I can then, if I want to start up multiple parallel threads to compile lots of modules in parallel, which I can, but I'm really GHC -- make, then I ask Ben again for permission. I say, could I have another token to create a thread? You say, yes, Simon, be my guest. And you hand out several. And then Alexi comes through and says, could I have something? Ben says, no, Simon's got them all now. But then I have to give some of them back, and then you could hand them to Alexi. But the idea is that Ben never hands out more than 64. Right? Yeah. So there's kind of one central manager for permissions to spawn a thread. And all the separate GHCs or Cabals or linkers communicate with the central manager in the same way. Yeah. So kind of cool. And again, it makes a difference in real life. And that's what we're trying to do. Okay. Tell us about stack snapshots.
Yes, so this is the first step in our long-standing plans to finally get some sort of form of backtraces in Haskell. In particular, you might have heard, and you will hear about this exception backtrace proposal. This is sort of the first step in that direction. So in order to offer a stack trace to the user, of course, you need to have some way to capture the state of the stack. And this is something that Sven Tenney was working on, and we managed to land for 9.6. We now have first-class ability to take the current state of the stack and freeze it on the heap, allowing the program to continue running potentially, but then have a persistent copy of the stack as it was captured, and then be able to later in 9.10, as we'll see, we'll be able to actually decode these stack snapshots into sort of human-readable stack traces, and that will go nicely with some future work that we'll also hear about in just a bit.
Thanks. Ryan, yeah?
Stupid question. How does that compare to the backtrace you get if you compile with -p prof?
That's a very good question. Let's address that. Okay. Yes. So actually, as we'll see, the exception backtrace proposal has several different mechanisms for collecting stacks. This is just one, but I suspect this is probably going to be the most widely used one. Profiling is something that is great for a debugger, diagnosing performance issues. It's not so great for deploying to production because of the overhead involved and the fact that profiling ultimately is going to affect simplification and therefore the optimization available to the compiler when compiling your program. And there's quite a few at least two other mechanisms as well, in addition to profiling. You have has call stack, which we've had for quite some time, and also the dwarf native backtraces. But all of these have various trade-offs. I suspect among the four options that we have, this native, what I've called a native stack, Haskell stack trace functionality is probably the most suitable to production use. It gives you sort of the best detail while having essentially no runtime overhead and not affecting the optimization of your program. So
Typically you'll grab a snapshot when something has gone wrong.
That's right.
Yeah.
Yeah.
So until then, nothing has changed through execution. Yeah. So it's yeah. Thanks. Well, I think you were going to say a bit more about that shortly. Right. Yeah. Okay. Fine. Right. Last thing I think from 9.8 is this is a proposal about extended literals. So we've got lots more data types, of fixed widths, int and word, widths of 8 and 16 and 32 bits, and now we can write literals of those types as well. So that's a good thing. Sylvain, I think, made the proposal, and I think did the implementation as far as I remember. But I do want to stress that every release, including 9.8, has a lot of groundwork going on. There's bug fixes, there's optimization improvements, there's improvements to the debugging and performance and testing infrastructure. It's just like I feel as if I sit under sort of fire hose of code reviews and often bug fixing in the type checker or in the optimizer. And if the optimizer gets a little bit better in some cases, that isn't like a feature that I would tell you about here. And yet collectively they make a difference, and lots of people contribute to those kind of things. So as well as these sort of visible, again, these bits are the visible bits that poke above the surface, there's quite a lot more underneath done by unsung heroes, many of whom are in the room. Okay, quick look at what's happening in 9.10. So this will be shorter. So 9.10, the idea is we're going to fork the tree in around about January, with a release expected around about March or so. Yeah. I think probably we're not expecting a lot of big new things on the language front. We might finally get all patterns and a little bit more progress on various things here. Type template Haskell and unlifted bindings. Oh, the whole unlifted data type stuff is a gift that keeps on giving. GHC gradually keeps getting, slightly dealing with unlifted data types slightly better. More on cross compilation. So, do you want to tell us something about cross compilation, Ben? So this is another.
There's a lot to say here, but I will try to keep it brief. Right. So ultimately, the point here is that we now have several platforms that we support: WASM, JavaScript, and increasingly ARM, which is really, and RISC-V for that matter. Yep. That often you don't see on a developer's desktop, and so but you still need to produce code for these platforms, and so ultimately we need some way to be able to provide a first-class experience to developers who want to run their compiler on their Apple or their desktop machine, but then produce code for other platforms. Of course, we have supported cross-compilation for quite some time now, but it's long been sort of second class. It's inconvenient. You need to download or build a second binary distribution. Whereas other languages have shown that you can actually have really great developer experiences in a cross-compiled setting. In the case of Rust, they've shown that you really can. It's a matter of just Rust up, add a target for x86-64 or ARH64, and all of a sudden, 30 seconds later, you'll be able to build code for ARH64. We want to offer a similar experience if we can, especially given the prevalence increasingly of WASM and JavaScript. And so this work that our intern at WellTyped, Rodrigo, did over the summer is just the next step in that. This is, of course, something that Loyota and the team at IOG have also been making really great strides in. But generalizing GHC to be a compiler, which you can just say at runtime, GHC --target, or compile time rather, GHC --target, ARH64. And all of a sudden out will pop ARH64 code, and then integrate that into GHC up and Cabal and all of the tooling that one would expect to be able to provide a really great experience for users of the compiler. Does that answer? Okay.
I love to see it happening, but I haven't got a clue about how to do it or why it's so hard. But just tell us about diagnostics as JSON as well.
Oh, that's right. Yes. Let's see here. Right. So this is work that has been going boy, this was a HF proposal actually. For a long time, users have been asking for sort of more structured output from GHC, the ability to get errors as structured documents that maybe not. Increasingly, users are using HLS, but still there's space for the sort of the lighter weight editor plugins and such that you can really that can find use in more structured output from the compiler that does not require linking against the GHC library. And so we've long had this dedump JSON flag, which will kind of approximate this, but was never really first class. It was always never well documented and never stabilized. So Ben Belloc has been putting effort into trying to come up with a really defensible mechanism where we can say, this is the format that we will produce, this is how we are going to evolve it going forward, and this is how end users can use it in their integrations with GHC.
As someone who's never really used RISC-V much in practice, is there like a particular use case that is motivating a RISC-V backend? Is there something that's driving that work?
At the moment, I think it's primarily interest. These are Sven and Moritz. I don't know their individual motivations, but I think it is. I think this is going to be an architecture that we'll see more and more, especially in a sort of embedded or settings, and we'll have to see. But it's certainly helpful to have GHC run in more places. Yeah. Let's see. What do we have? Yeah. All right. Yes, we have been focusing a lot on profiling recently. So this is something that work that has been sponsored by a client of ours, developing various tools to help them understand why their program is slow, why their program is looping, why their program, all of the sort of pathologies that you typically find in a Haskell program. We're one by one sort of picking out the top of the list and developing tools to help them understand those problems and avoid them. So in 9.10, we're going to have one feature, this orig thunk info. So in particular, it's very common that you'll find in your Haskell program, you write, let x equals x somewhere in your program, and you try to enter x, and all of a sudden you get a loop error, right? And that's not very helpful. That's really really. Yes, exactly. Where did I go wrong? And this is something that's actually very difficult to debug because in general, these problems can actually manifest in rather large heaps, which are rather hard to disentangle after you've entered because the actual thunk that you entered is actually been overwritten by a black hole by the time you find out that you've looped. So you've actually lost the information necessary to identify the culprit in many cases. This feature, orig thunk info, is essentially adds instrumentation to the compiler, which allows at runtime to examine the heap and sort out, oh, well, it was this thunk x in my original program that I entered that is inducing this loop. This is something that we found very, very useful in debugging, again, a client issue, and I think we'll find uses in our users, for other users as well. Was that? Thank you. Okay. Right. In addition, we're going to get heap profiling support in non-moving GC. This is actually great because this is a bit of non-moving GC work that I am actually not responsible for. So Teo, our contributor, has been working increasingly on the non-moving GC as he's found his employer has been finding it increasingly useful. So it's now gaining heap profiling support. We're getting more flexibility in info table profiling and info table provenance emission. So as Simon described earlier, we've long had, for several releases now, had this info table provenance mechanism, and increasingly users are wanting to ship these this information to their users. But for a variety of reasons, either because of binary size or because of runtime overhead that this distinct constructor table mechanism that Simon alluded to earlier incurs, we kind of want we don't want to go whole hog in the direction of sort of emitting this info table provenance information. We want to be a little bit more surgical in where we emit this information and which distinctions, how much we let it affect code generation. So we're sort of growing, GHC is growing more knobs to allow the user to be more explicit about what information they want out of their info table provenance. Further, we have further improvements in the non-moving garbage collector, further pause improvements. As I mentioned earlier, Sven in 9.10 has implemented stack snapshot decoding. So this is, again, in service of this exception backtrace proposal that's been sort of long on the verge of being merged, but I think in 9.10 it's actually going to happen. We're making great strides in getting the proposals through, and I think we have a really great design at this point. I'm very happy with how we now, what started off in this proposal as a very sort of niche, let's just hack on a backtrace to in some exception type, now is sort of blossomed into a far more generalizable general purpose mechanism for annotating metadata on exceptions. And I think, I hope you'll find it useful well beyond just simple backtraces. We may be getting an IOU ring based IO manager for Linux. This helps scalability in many server applications. And of course, there's anything that you might be working on. So I'm not sure. I think these are just the sort of things that we've been focusing on. But ultimately, there are many people in this room who are no doubt have things of their own that they'd like to see in 9.10. So please, let's hear. Nobody, not a single. There we are. Okay.
I am, but it's a small thing that's been going on for a while. It's related to linear types, as everything I've been doing in the past few years. And so currently, when you write a let expression in with linear types, it's not going to be understood as something binding linear variables, which is immensely silly and absolutely terrible UX. And I apologize. And I thought it would be an easy fix. After all, having case understand linear types was a one-line fix at some point. And so linear lets took me like a year, basically, to like 1 day a week at a time. But it's been a long road to fix all the paths that were involved in type checking lets. It's currently a merge request that I need to fix a few things for. But it's going to land way before 9.10 cutoff. So this one is going to be in.
Oh, there we are. Jeff?
Hello, I'm Jeff. I work at IMG with Lita and Josh. I wanted to point out two things. We had an intern, Bartek, who did the export deprecation implementation. And what was the other one? I mentored him. I should know this. And the instance deprecation implementation that, and I wanted to congratulate him on a successful internship. And he also had, I think, more robust warnings for record wildcards. That was one. The second thing I wanted to point out was I have a merge request, like all of you in this room, that is in flight and is so close to being merged. But what it does was add the links to the Haskell error message index to the error codes. And all I need to do is check that the terminal is smart enough. All the other logic is done, and most of the effort was not actually on the implementation. It was fixing the CI test suite to not completely melt down when it sees links. So please search for this on GitLab, and then please contribute, because I do not have time to work on it anymore. Thank you. Yes, that is a healthier and better way to say that. Yes.
Is there any work, the JavaScript land, things that we didn't cover in the...
So in JavaScript land, we are missing the optimizer that was in GHC.js, and the reason for that is that, according to Lita, it tried to do too much and was a buggy mess and was not maintainable. So I also, the current plan there is to revise the IR that we compile STG into so that we actually have a good optimization target. And that also is very close to being done, but I have not had time to really land it, and there's a bug we have to work on, or we're going to pair program on this week. So, you want to add anything, Lita?
I don't think it's close to being done, but we're working on it.
So I'm going to sneak in here some Cabal and Hackage updates as well. Not coming in 9.10, but things that have already happened. And in Cabal land, it's largely been incremental improvements in stability. The one new real headline feature is that there's now the haddock-project command. So if you've got a project with many different packages that are all like sort of depending on each other, you can run Cabal haddock-project, and it'll generate haddocks for all of that stuff, all hyperlinked together, to get you nice local documentation for the whole project at once. Also, just like GHC has error codes and Stack has error codes, Cabal error codes are now underway with our Haskell Summer of Code, and are going to be getting added to the index, and we'll be filling those out too. And so we're going to get better structured error messages for Cabal. And then on Hackage, hopefully some of you have already noticed this, but it is new since the last in the last year. So the big headline feature is there are reverse dependencies directly on Hackage, and you can follow through and trace the chain of all of those. And along with that, less noticeable, but I really encourage people to use if you're interested, is we've got a very rich now notification set of features that you can turn on. We didn't turn them on for maintainers by default because we don't want to spam you, but you can go to your account settings and turn on all these email notifications that will let you know, for example, if a dependency is updated in such a way that it breaks the bounds on a package that you are maintaining. You'll get an email about that. If there's a metadata update made to a package you are maintaining, you will get an email about that if you opt in. And a variety of other useful things for maintainers to know. Also, if you upload a package and the builder tries to build it and it fails, you will get an email about that if you opt in. So please do opt in, try out the emails, and see which settings are useful to help you manage your Hackage packages better. Oh, yes, and the one more thing. These have existed and for a long time, but only in the last year have they moved out of experimental so that you can upload to Hackage a package with multiple exposed public libraries. We have in flight the work that they won't display very well. They'll only see the haddocks for one. We're going to fix that. But now you can upload and experiment with them and depend on them, and they're fully supported and in every other way. So if you've had like a whole bunch of packages that you thought these should really just be multiple libraries exposed from the same package because they all move in lockstep for whatever reason. And there's a bunch of use cases I won't go into. You can try that out now and start really doing that in earnest.
Excellent. Is there going to be a blog post or something about the notifications work? I was actually unaware of that as well.
We did announce it.
Okay.
I was just saying we did announce it on, but just on the discourse. We haven't been very vocal about this. So yeah.
Actually, Finley, you've been doing work on Haddock, right? And improving performance of Haddock. Do you want to talk about that at all, or? Yeah.
Yeah. For well-typed, I was doing work on reducing the memory usage of Haddock and making, landing high Haddock is like the biggest thing in this work, where documentation gets generated from interface files, and so along with that, you get like recompilation avoidance in GHC, so you can avoid recompiling your project just to generate documentation, and currently working on the Cabal feature that also would help Cabal not trigger that recompilation. So yeah, Haddock was going to perform much better in future releases, and hopefully we will have easier recompilation avoidance during documentation generation. Yeah.
All right. Did... Okay.
Which was that clearly the Hackage rich notifications were pushed forward as a Hackage notification, but nobody was opted in, so nobody heard of it.
Anyone else? Oh, there we are. Yep.
I mean, I feel like I'm cheating a little bit because Simon mentioned all of this amazing work that people are doing on making serializable errors and you know, all of this stuff, because it used to be that, you know, GHC IDE would actually figure out what error you had by doing regexes, right? And it would extract names out of them and things like this. And now we've got structured errors. But so what I've been working on, and there'll be a talk about it in an hour or so. Essentially, it's a post-processing plugin for specifically so that you can rewrite type checking error messages for when unsatisfiable fails you, when it's not sophisticated enough, when your DSL just has some type machinery inside of it that is just too dang good to expose to, you know, the person who's actually using the surface level DSL. The hope is that you could use this post-processing mechanism. There's a few other uses for it. Maybe I shouldn't spoil the entire talk right now. So yeah, I'll just leave that to later.
Excellent. All right. Anything else? Okay.
Let's move on. So there's a couple more things I want to cover before we finish. So one thing is just to talk briefly about the role of the Haskell Foundation and what's happened in the last last year. So you remember I put up a slide that's more or less like this time last year, which is to say Foundation's been really helpful to GHC land for improving coordination across the ecosystem. I put up some particular points here, but we have had material improvements in this coordination. Right, we're actually holding regular meetings with our stakeholder compatriots in other parts of the ecosystem, like the stat folk, the hackage folk, the cabal folk, and GHC up and HLS. Right, Ben spent a lot of time in these meetings, I think. But these have tangibly resulted in some changes, right? So now when GHC comes out, GHC up is out the same day or later that day with the new release of GHC, and HLS is not far behind. And we're working much harder on getting the GHC up you get isn't a sort of postfix on GHC. We've actually tested the release with GHC up before as part of CI. So this all makes a difference. So that's in general. I wanted to give you two other specific examples of things that have happened this year. One is that David, under the auspices of the Haskell Foundation, did a kind of survey of a selected group of Haskell users. It wasn't an open thing, but he chose a reasonably large group, processed their results, produced a report that is, I think this is the report that he produced about, as it were, users' desires for what we might do in GHC. And then he discussed that again with us, and we did quite a lot. One of the top thing was to be more clear about how GHC as a project is managed, because it is now quite a large open source project with quite a lot of people who are, both their time and their emotional energy and sometimes their companies are deeply connected to the decisions that they're made. So we owe it to be a bit more transparent. So now there is a brand new GHC headquarters homepage. This isn't primarily technical, it's primarily organizational, right? What are we doing and how do we organize ourselves? And so here's the URL, you can go and have a look. It has pointers to finding out what is going on with GHC and also how to contribute. So in particular, identifies much more clearly than before the GHC team, right, which is the bunch of people who actively contribute to GHC who have commit rights, right? So we now list them explicitly with their areas of expertise. It's a anybody can join the team simply by saying, I would like to join the GHC team, and then you get a standard invitation to come to the weekly meetings. The commitment you have to make is that you're then up for saying, oh, could you review this patch, this merge request for somebody else, which is in your area, right? So it comes with some power and some responsibility, but the idea is that anybody can sign up. It's not a kind of closed shop. So have a look at this. The second thing the Foundation did during the year, which I think was in GHC land, this isn't a Foundation summary, this is just the GHC intersection, was to run the GHC Contributors Workshop, where many of you were at. So do go to this thing that looks like an invitation to the workshop, but if you scroll down, you'll find the program. And in the program, you'll find videos and slides for all the talks. So this is kind of like incredible. If you're interested in getting arms deep in code for GHC, this is a fantastic resource. It contains talks by the people, so Loiter and Cheng and so forth, talk in detail about the WASM backend and the JavaScript backend. You can get a lot of technical information here. So do take a look. But that was just organizing this. at Zuri Hat was a pretty significant organizational effort. We're really grateful to the foundation for doing that, because we didn't. And the third thing I wanted to point to was a long conversation, which at times has been tricky in the past, but which has settled down in a really good way between principally between the Core Libraries Committee and the folk involved, particularly in GHC, because there was this question about, originally the base library was kind of in GHC land. Well, it was just what GHC exposed. That's why it was called base. But now the Core Library Committee is in charge of it, and there was a bit of tension about, if GHC guys just sort of add something to it, or if the GHC Steering Committee, to make some enhancement to the language, adds something to the base library. Now the Core Libraries Committee feels a bit undermined, and that's not good, right? So we had miscommunication because of that. So we've sorted all that out now. It's got this nice structure, which I'm going to share with you because I think it's helpful to have in everybody's head. So here it is. The base library, right, is curated by the Core Libraries Committee. And when I say curated, I mean they're in charge of the API. Exactly what is exported from exactly what modules, with exactly what types, and their performance characteristics. Right? So can't run out and arbitrarily change performance characteristics. So any changes to that API, we need to submit a Core Libraries proposal for. However, underneath that is a bunch. These three libraries packages are part of GHC's internal implementation. We previously had something called GHC Bignum and GHC Prim. GHC-internal is a new one, right? And it can contain whatever code seems good to the GHC implementers. You should think of it as being, that's the cogs and the wheels inside the machine, right? This is the surface. But if this guy, base, re-exports something like, I don't know, lists, which are actually defined down here, then it's no good us saying, well, we decided to change lists down here, and oh, and by the way, you just re-exported it. Not our problem. No, if it changes this API, we have to negotiate. So there's a transitivity involved, right? And then furthermore, the GHC Steering Committee may do things like snapshots, stack snapshots, or I don't know, tuple naming things. And we don't want to uncritically add those to base, because then they're part of this very strong stability goal that the Core Libraries Committee is going to maintain. So the GHC experimental package is meant to be under the curation of the GHC Steering Committee, and they're going to add things to there, and you're welcome to use them, right? And but they don't come with the same stability guarantees as the base library. So I put major goal stability here, goal here, and not a goal here. Does that make sense? Right? And these libraries here, you are welcome to import, but it's at your own risk, right? We will make no attempt to, we will not apologize to you if we break your library because you imported something from GHC internal. If there's something from GHC internal that you want to use that's important to you, then you should appeal, you should either get it in experimental or in base, at least, to, because that will then tell us that's something you care about, right? That we should be careful about its stability. But there's an awful lot in here that you don't care about, and we don't have a way to distinguish that. Does that make sense? So I think this is very helpful. It's all set out in this proposal, which is a Haskell Foundation proposal. And I will just remark, you can look up Conway's rule, right, that which is that the technical structure of software projects evolves to reflect the organizational structure of the groups that are building them. And there's a good reason for that. It's kind of tongue-in-cheek, but there's a good reason for that, which is that it helps with communication. Each group knows what it is doing and doesn't trip over the other. Does that make sense? So I regard this as quite a big victory, in that an area that was previously, there was no hostility, but there was tension. I think the tension has been greatly ameliorated by doing this. And the foundation played a big role in making this happen. Okay. A quick roundup of GHC proposals. Yes, Christian.
So things that are in experimental but then become stable and move to base, will they stay in experimental forever, or will they?
Right. So what about
on which package do I need to depend?
So initially you'll depend on experimental, right? And then you may say to the Core Libraries Committee, guys, this is really useful to me. I use it every day. It's been there in GHC for several years. It should really be stable. And they say, fine, Christian, we'll put it in base, right? And then we might use those deprecated exports to suggest that you don't import it from experimental anymore. You import it from base, right? And then several years after that, we might, GHC is turning into this sort of decades-long storyline of deprecations and gradual shift. Because we don't want to break your code gratuitously, right? Or maybe you decide to leave it in experimental forever. I don't know. That would be a case-by-case choice. Does that make sense? Yeah. Anyone else? Is this keeping this separate in your head? I think is quite important to understanding what to do. Yeah.
So the proposal is accepted, as I understand it. Is there a roadmap for when we can actually expect to see these new things on the bottom of the slide?
Yeah. So there is 9.10, right? Yeah. So 9.10 will have this, right, possibly empty, right? Because after all the code is here anyway. The idea is we will probably, in order to implement stuff in here that we want to, stuff in here that needs internal stuff, we may need to move code out of current base into here, leaving shims behind, right? And there may be some libraries, some functions in base that are manifestly internal and were never intended to be for public consumption, and that the Core Libraries Committee may or may not agree to remove them from base and have them exclusively here. But that's a future conversation. Does that make sense? But these both will exist in 9.10. So as sort of placeholders to be filled out. Yeah. Okay. Quick roundup of GHC proposals. I mentioned them quite a lot in the headings for slides. So thanks to Joachim for getting these numbers. So we're up to 394 active, genuine pull requests. If you look on the website, you'll see 600 and something, but the others are somehow not proper proposals. So other PRs that weren't proposals, fine. So we've actually had 394 proposals since it began, right? 43 new ones this year. The number under discussion, meaning that they haven't been closed down. This is before submitting to the committee. They're not under committee's purview. They're simply under community discussion. The author hasn't yet submitted them. 66 of those. That's a few more than was in the case last year. Under review, the committee has got in its inbox 9 that's got to decide about, which is a little bit more than we had at this moment last year. That tends to vary over time. The total number of accepted proposals, 124. So we accepted 18 new ones in the last 12 months. And rejected 2, and 20 proposals got implemented this year. That's pretty good. Right? Remember, accepting a proposal is not a guarantee by anybody that they'll be implemented. Somebody has to step up to do that. So these are the ones that I won't read them out. These are the ones that have got accepted this year. Ryan.
One thing I wasn't sure on that slide, some of the proposals that were submitted were amendments to previous proposals. Are those included under the accepted tab, or are these a separate category? Okay.
Yes. So some of those 18 are simply amendments to existing ones. Just putting up here the list of accepted ones. I shan't read them out. Here's some more. Okay, I think it's painstaking, sometimes frustrating, but I think it's basically a healthy process, this. Okay, here are the people you should applaud for their hard work. This actually is quite hard work doing this. I'm really grateful to all of the people who serve and the people who served in the past on this group, because it's yeah. Well, closer to the mic. Sorry. Yes, thank you. Let me say that louder. I'm really grateful to the people who do this work. Thank you so much. Yeah, we can applaud them. Thank you. Which take me through. Let me just go back to the GHC team, because I want to Ben to just fill in a little bit about this, about the sort of the CI process and the number of tickets we got. This is so when I showed you that GHC HQ thing and said, here's the GHC team, we and anybody can become part of it. We wrote down a list of all the people we thought were active contributors at the time, and wrote to them all to say, do you want to be a member of the GHC team? With the powers and the responsibilities that has. And these were the people who are currently signed up. So big thank you to all of them. So GHC is quite a big project. And these are the people who actively contribute to GHC on not a daily basis, but actually you'll be able to see in the next few slides how much they do in effect.
Yeah, I'll make this quick. But yes, thank you, Simon. I think on the whole, GHC is quite a healthy project. So here we see, looking at number of contributors, how many have made N commits per year over the last year, or for each of the years, going back to 2009 or so, last 15 years or so, and we see that there's a nice upward trend here. And this 10 or more commits this year is roughly that list that we saw on the previous slide, right? We have around 30 people who are quite active, and not only in commit, actually writing code, but also reviewing and offering feedback, helping our contributors. So I think this is quite a healthy story. But this, on the other hand, is where we need help, right? So here we have, we see that this is not a good trajectory, especially given this trajectory here. This is much steeper than this, you'll note. So if you can do anything, it's open GitLab, go to gitlab.haskell.org/GHC tickets. Choose one and fix it. We would all be very, very appreciative. Yes, Lexi.
On the contrary, a large number of open tickets is a sign of health. People care enough about the project to file bugs.
That is quite right. But ideally, they would, We'd also like to close some at some point, though, as well. That's sort of where we need your help. Let's see. Yes. So as you know, HF has been really helpful in offering to fund Brian Richter, who is now our DevOps engineer. He's been invaluable in helping support GHC development as well as other projects in the ecosystem, and this is really important. I think we need. Having somebody who really has the bandwidth and focus to be able to evaluate our infrastructure, not just within GHC, but also more broadly across the ecosystem, and be able to help out honing that infrastructure where needed. So this year he's been focusing largely on characterizing the fragile tests within GHC on the GHC side, and looked a bit at notarization of our Mac OS artifacts, and I think we now have a plan for doing that. I'm not sure it's going to happen for 9.8, but we shall see. And generally trying to make our infrastructure more maintainable. So for a long time we sort of muddled through because it was me and a few other people. Now we have Brian, and Brian has been working to further cast even a wider net in making our infrastructure sort of a more community asset and less of something that is just GHC responsible for overseeing. Likewise, we've made really great strides in, thanks to Brian's help, in reducing spurious, the reliability of our infrastructure. So, over the past year or so, we've had roughly a 50% reduction in the number of spurious job failures, which I think is really, we've gone from 85% or so to greater than 90% passing rate, which is really, helped. It makes it much nicer project to work on when you don't have to randomly restart 3 jobs that spuriously failed when you submit a merge request. We have, of course, been continuing head.hackage. Last year we reported that we were advocating for a proposal, GHC.x.hackage, which based upon our head.hackage infrastructure. The fallout of that proposal was, well, there may not be enough interest necessarily for end user use, but head.hackage continues to be an invaluable resource for testing GHC and ensuring that we catch real world issues from on-hackage code as they are introduced in the tree. And I think Ryan is somebody who really deserves to be noted here as being somebody who's really looking carefully at head.hackage and making sure it remains building and catching bugs when they occur. And this has, in fact, really caught real bugs. And I think our releases are are in much better shape by the time we start the pre-release cycle because of head.hackage. Right. So let's see. We've as well been introducing support for nightlies for end users to be able to easily get nightly builds of GHC via GHC Up. We hope that this is a useful resource for our users, especially those who are wanting to use sort of pre-release features. And head.hackage, of course, is a great resource for them as well. Likewise, And finally, Hadrian, we can finally, at long last, we put the last nail in the coffin of the make build system. It was dropped in the tree as of 9.6 after a long, long road. I think we started working on Hadrian. Simon told me about Hadrian when I started working on GHC in 2016, I think. And now here we are in 2023, and we just barely removed the make build system. So it was a very, very long ordeal. But I think the result is actually quite good, and we managed to work with our packagers to address their needs. We're still sort of working on continually, improving the build system, and certainly, we're now starting to reap dividends of all of this work, especially with the cross-compilation work that we're now undertaking. So, in general, this is, a community project, and there are countless ways in which you can be involved. We certainly have no shortage of tickets to look at, but as well, there's so many opportunities within the ecosystem, from the GHC Errors project to various work across the ecosystem enabling JavaScript and WebASM support, to looking at compiler performance features. See the newcomer label on the BitTicket tracker for ways in which you can help. And thank you for listening. I think that was, yes.
To that it's kind of tempting to see GHC it's a 33-year-old project now, and it's awfully tempting to see it as something that will happen anyway, right? Just sort of out there, and I can use it. But this is the Haskell implementers meeting. Quite a lot of you have spoken today because you're active contributors. Some of you not, but I would really love you to become active contributors, because we're only going to succeed if GHC is our project and not, Ben's project or my project or some anonymous team. It's really, really significant that we think of it as being something that we are doing together. It's quite, 33 years is pretty old. That's slightly older than my eldest son, who is now an active contributor to to HLS. So you've got to breed them. But that's, it's quite rewarding to contribute to something that's as long-lasting and as I would like to think, as intellectually and organisationally important as GHC is. So please do get involved. And if you find yourself bouncing off in some way, you try to get stuck in and things haven't quite worked out, or you felt someone was unfriendly to you, or just that you couldn't find a way in, then talk to Ben or talk to me or talk to somebody. Don't just sort of go away and cry, all right? Because particularly in a big geographically distributed system, it's easy to accidentally miscommunicate. So go the extra mile and write to Ben or write to me, or talk to us later during ICFP. Thank you so much. Great. Yep.
Hello, yes. This is a question for Ben. So Make has been finally deprecated. Are there plans to remove the vestigial parts of it from the G... Oh, I must fetch upstream. Excuse me. Thanks.
Yeah. Good riddance, I would say.
I actually have a question for the room. So I'm sort of the not so secret person behind these error message codes for years. Even sort of before the HF happened, we started to put the error message codes into GHC, and then I encouraged the HF to sort of take this on. And there's been a lot going on. Many other people contributed. I didn't do any real hard work. I just sort of stood behind the scenes and cheered on. I'm curious, do people use these error message codes? I mean, I see other people contributing to this and other projects starting to use it, but I don't have a good sense. Was this a good idea? Like, what? Can I have a raise of hand of people who have actually looked at that errors.haskell.org to get information? Okay, that's pretty cool. So, I mean, can I get like nod? Like, was it helpful? We have yes. Okay, good. I mean, or you have students who maybe there's a bad sample set because I think a lot of people here, and I recognize that, but maybe you have students or other colleagues. Anyway, even a little feedback was helpful there. Thank you.
Maybe you have time for like one or two more questions if anybody has some.
So this is more me being out of the loop. What's the status of the FAT interface files? Is it in 9.10? Could we have fat interface files for base as a separate download? How difficult would that be?
I believe there is actually a ticket about that. Yeah. So this prefer bytecode work actually relies on. I believe so currently we do actually have some core interface files. If you opt in, we don't ship binary distributions with this with such core in interface files, and there's a reason for that, and that's but size. This is yes, we could optionally. We could ship this as a separate sort of artifact that one could download. I think there's a real question here it's a distribution question as how do you actually ensure that how does the user actually download this, install it, and ensure that GHC can that they're compatible with the interface files that would have been in the binary distribution that the user originally downloaded. Either that or we need to produce 2 binary distributions for every platform that we offer, which is not really a great option. So I think there's some design work here, but I think a lot of the similar questions need to be answered in the cross-compilation work. So I'm hopeful that because for instance, when the user wants to start, they download their binary distribution, you have a runtime retargetable compiler, and all of a sudden they say, oh, I need to compile for AR64 now. Well, you need to download a whole bunch of things for the runtime system text, the core libraries for AR64 as well. So this sort of adding things on to an existing binary distribution is, I think, something we're probably going to have to address one way or the other. And this is just another example of this. Debug information is another example, and IPE information. There are many things that would sort of be helped, I think, with such a mechanism. But yeah, it's sort of a cross-project piece of work, since this is ultimately probably something that is pretty squarely in the GHC up category of area of responsibility. So yeah, there's some design work there, I think. Yes. Oh, sorry.
Unfortunately, we are out of time. Sorry about that. Oh, the question is, where can we see where the lightning talks are? So if you go to the program on the HIW track on the ICFP website, we have a list of them. I've noted that you submit a lightning talk. I haven't had a chance to add yours yet, but I promise you I will get around to doing that. So yeah, sorry about that. I have to manually add these, so I haven't had a chance to get to my laptop and get the forums modified appropriately. But that is in the works, I promise. All right, well, that is all the time we have, so let's give a round of thanks for our speakers, Simon and Ben. All right, we're now going to have a 30-minute social break. We'll be back at 11 o'clock.